Good morning, ladies and gentlemen. I hope everybody is having a great day so far. Again, I apologize that I am not there today. I will be in meetings all day over at Liberty High School. I will have my computer on me. I will have my email pulled up. So if you have any questions over this or about anything, just shoot me an email. I'll get back to you pretty quickly. So today we're going to talk about electrons. Okay, we've been talking about elements, atoms, the periodic table, ions. But we're going to kind of take a step deeper and look specifically at this particle called an electron. Okay, so if we recall about an atom, okay, the atom is the smallest unit of matter. Okay, it's the smallest thing we could possibly have. Okay, and these atoms are made up of two main parts. Okay, and the first part is what we call the nucleus, which is this part right here in the middle of the atom. This part includes our protons and our neutrons, okay? And then outside of the nucleus, we have this ring around here, okay? And around this ring are where our electrons exist, okay? Now this ring, we call this an electron cloud, we call it an orbital, we call it a shell. All three of those things mean the same thing. So if you see any of those, this is what it's talking about. It's talking about this ring where the electrons are orbiting, okay? Now, electrons orbit around the nucleus, okay? This works just like the planets orbit the sun, okay? So just think of it like that. So when we look at electrons in specific, okay, there's a couple things that we need to know. First and foremost, electrons are negatively charged particles, okay? They have a negative charge, okay? Now, secondly, these electrons are found outside the nucleus of the atom. So we just saw that, right? They circle around the nucleus of the atom. Now, when they circle around the nucleus of the atoms, they circle in different orbits or levels, or shells, as we sometimes call them, around this nucleus. So if we look over here at this atom over here on the right, we see that we have one shell here that has 2 electrons on it. And then we have another shell that has 6. Okay, the reason we can have more than one shell or more than one orbit is because each orbit can only hold a certain number of electrons. Okay, so for instance, the first shell can only hold 2 electrons. The second shell can only hold 8. Okay, so if we look here, we have the first shell with 2. Okay, it can only hold 2, and then the second shell can hold up to 8, but right here we only see 6. Okay, so we just need to be aware that electrons orbit in these shells. Okay, and each shell can only hold a certain number of electrons. Next, electrons move extremely, extremely fast. Okay, plain and simple, they move extremely fast. The mass of the electrons are nearly insignificant to that of the mass of protons and neutrons. Okay, think about this. When we talk about the atomic mass of an atom, we are talking about the protons plus the neutrons. Okay, the reason that is because the protons and neutrons make up a majority of the mass of the atom because they have a greater mass than the electrons do. Okay, so when we're trying to find the number of neutrons, we always use the atomic mass minus our protons because those are much more heavy particles, whereas the electrons hardly weigh or hardly have a mass that you can even measure. We know that the number of electrons is always equal to the number of protons unless we are looking at an ion, which is where we're losing or gaining electrons. Okay, and then lastly, electrons are involved in the formation of chemical bonds. So electrons could not, if they did not exist, nothing else in the world could exist. Think about it. Hydrogen and oxygen have to bond together to create water. If there's no electrons which are involved in the formation of bonds, oxygen and hydrogen could never bond together, therefore it would never exist. So electrons are so vital to everything in the world. Now, when we talk about electrons, there's this big word that looks crazy, but it's a big thing when it comes to chemistry, and that is valence electrons. Okay, I'm going to skip this first blurb because I really only want you to know the second. Okay, the second blurb down here says, these are the outermost electrons in the atom. Okay, plain and simple. The valence electrons are the outermost electrons in the atom. So let's look back at this picture. I have two shells of electrons in this atom. Okay, if I were to ask you what are the valence electrons, you should be able to tell me it's the ones on the outermost shell. If I asked you how many valence electrons there are, you should be able to look at this outermost shell and tell me there are 1, 2, 3, 4, 5, and 6 valence electrons. Okay, so when we talk about valence electrons, we are talking about the outermost electrons in an atom. So again, these electrons orbit in shells, and each shell can only hold so many. Okay, we talked about that. I don't want to go any more into that. But what we do need to get into is how we determine the number of valence electrons. Now, there's two different ways. One way is drawing an image like this, which we will do a little bit later, but not now. For now, we're going to make it a little easier. Okay, so right now, I would like for you to pause this and get out your periodic tables if you haven't already, because you're going to add some things to it as we go through this here. So, the number of valence electrons of an element is determined by its periodic table group or family. Okay, if we look at our periodic table, each column is a group or a family, as we call them. Okay, so each of these families you should have already labeled 1 through 18 across the top. Okay, that should already be done. Now, here's what I want you to change. Okay, above group 1, I want you to write a 1. Above group 2, I want you to write a 2. Then we're going to skip all of these guys, and I'll tell you why here in just a minute, and go straight to group 13. Above group 13, I want you to write a 3. 14 a 4, 15 a 5, 16 a 6, 17 a 7, and 18 write an 8. Okay, now what each of these numbers mean is every element in this group, so let's look at group 1, every element in group 1 only has one valence electron. So it only has one electron on the outer shell of the atom. Group 2 only has 2 valence electrons in the outer shell of the atom. Now, we skip groups 3 through 12 because the transition metals do not really abide by many of the rules that we've talked about with the periodic table. Okay, they're kind of oddballs. They just hang out there. They don't follow the rules. So we skip these guys and go straight to group 13. So every element in group 13 has 3 valence electrons, which is why you should have wrote a 3 up here. Every element in group 14 has 4. Every element in group 15 has 5. Every element in group 16 has 6. 17 has 7, and 18 has 8. So if I were to ask you, how many valence electrons does carbon have, which is right here, you should be able to say, hey, it's in group 14, therefore it has 4 valence electrons. Okay, and that's what I need you to be able to do with this for now. Okay, we will get a little more complicated with this down the road, but for now, that is all that I need you to be able to do. Okay, so let's just look at a couple examples here. Oxygen, for example. Okay, and again, I just want us to see what this looks like here. Okay, so if we look at oxygen on the periodic table, okay, oxygen is in group 16. So it has how many valence electrons? It has 6. Okay, so if we look at this picture of an oxygen atom, we know that in total it has 8 electrons. Okay, and I know that because if I look back at the periodic table, the atomic number is 8. Okay, so when we look at this, we know that the first shell around the nucleus can only hold 2 electrons. So I put 2 of my 8 electrons for oxygen here. And then on the second shell, it can hold up to 8. But since we put 2 here, we can only have 6 more because 2 plus 6 is 8. So I have 2 electrons in the first shell. I have 6 in the second shell. So if we look, we have 1, 2, 3, 4, 5, 6 valence electrons in this oxygen atom. If we look back at the periodic table, we know that oxygen is in group 16, so we know it has 6 valence electrons. Okay, so just another example. Sorry for the craziness there. Another example I actually got rid of, so forget the other example, but when we're looking at this picture, I simply just want you to be able to know that that is how we are getting those numbers from the periodic table. Okay, so what I want you to do here is just talk over this with the person that you were sitting with. These are 3 very easy questions, hence the pretty simple here at the bottom. As soon as you answer those with your table, okay, what I want you to do is to get onto Google Classroom, okay, and you are going to do the practice that I have for you on there. Okay, it's going to be looking at different elements and how many valence electrons there are, okay, and also looking at ions. Make sure when you are done with that, I need you to turn that into Google Classroom, because that is what I will look at tonight when I'm done with my meetings. If this did not make sense, okay, you need to be able to understand what valence electrons are, and you need to be able to understand how to find them on the periodic table. So if that does not make sense, please shoot me an email. Please ask a classmate. I really do not care if you guys are talking once you get done with this, because somebody's going to pick up on something that somebody else doesn't. So help each other out. Okay? If that doesn't work, shoot me an email. I'll gladly respond as quick as I possibly can. All right, I am going to skip all that because I really do not want to get into that right now. So just stick with that. Go with that. Have a great day. Again, if you need any help, please shoot me an email. All righty, have a great one.